Welcome everybody to the live office hours. We haven't been able to do one for this class yet, so this is our very first one for the computer science class. Welcome. I'm Ryan Muth. You've seen me in the videos.
I'm Phil Miller.
And we didn't get any questions from you guys today, which we're kind of sad about. But what we're going to do instead is we're going to talk about some things that we find exciting that have been in the news recently. And by pure chance, we kind of both brought news articles that are related to artificial intelligence, and particularly a specific form of artificial intelligence called evolutionary computation. And the way that this works is we set up a program. Basically, all artificial intelligence is it's a type of programming where we, instead of specifying how the how the computer is going to follow instructions and what it's specifically going to do, the computer learns from experience how to build its own set of instructions or make its own decisions, right? And one particular form of that is evolutionary algorithms. And the way that these work is that we program the computer to generate a whole bunch of possible solutions, just basically randomly, right? And we take this as a population of sort of individuals. So they might have various different parameters and various sort of combinations of features that are there to solve a particular problem. And some classic examples are things like there's an online tool where you can involve a car, and the way that it involves the car is like where wheels are and where motors are and how big the frame is and how things are connected together and all kinds of stuff like that. And the computer will generate 100 different combinations of these specific pieces, and then it'll see in a simulator how far each of these simulated cars actually move, right? And that's what we call a fitness metric. It's how well a particular individual in this simulated population actually solves the problem. Once we know how well all the population individuals perform, we basically kill off the ones that are underperforming, and then we take the ones that are performing well out of the population, and combine them together to generate new solutions. And usually there's a little bit of noise in there. And the idea here is this simulates the evolutionary process. So the solution evolves over time by repeating this process of survival of the fittest, literally survival of the fittest. And the computer is able to generate often new solutions that people wouldn't have thought of, right? So this week I ran across a paper where it was a summary of sort of anecdotes from the researchers that are exploring these algorithms. And what it was is a compilation of how surprising and weird these different solutions were. And often it was really challenging to the researchers because they had specified specific things and they were hoping for specific kinds of solutions, and the evolutionary process either found shortcuts or found bugs in their simulations, or all these weird things that they didn't expect. And it was super interesting. And I want to show you a couple of them. So first off is the article itself. It's called The Surprising Creativity of Digital Evolution. And you can find this if you just Google the title there. You can find it. You can see there's like 100 authors on this thing, and it's because they surveyed a whole bunch of different researchers. So there's a lot of contributors here to see who helped with this article. But it's really fascinating and really interesting. And what was great is they included some links to some videos. And the first one I'm going to show you is you can full screen that, I think. The first one I'm going to show you, this is a simulation where they were trying to evolve individuals that were able to walk in this simulated environment. In this simulated environment, they have gravity and they have friction, and it's normally in air and stuff like that. And they were hoping for these evolved entities to have legs and things that look like the animals that we're used to. And they did get some solutions like that, but this one chain of solutions was a system, or a population of individuals that just got really good at falling. So what we have here is a guy, an individual that starts out upright, and it has a big weight at the top. And let's see what happens when they start the simulation. So it ends up flipping all the way over and moving all the way. And this was a great simulation as far as their, this was a great individual as far as their simulation was concerned, because it was able to move really far. And we saw just a couple other ones that are also like other ones that ended up leaping and doing different sorts of things. And the idea here was to try and get an individual that moved the farthest. And this one is like a tree that falls over at once. And they had to figure out a new way, so that a new way to measure fitness, to measure how well these individuals did by changing their metric from how far it goes when the simulation starts to doing what's called a potential energy relaxation. They let everything fall and then they check and then let it run after that. So it was really, really interesting for that one. There's another one here where they were trying to figure out how to get a robot arm to grab an item. And one of the challenges they made was to give the robot arm a handicap by not allowing its gripper to open. So they wanted it to pick up an object and move it. And in this case, they were hoping that with the gripper closed, the robot arm would sort of nudge it around. And what they ended up doing, let's see what they ended up, what the evolutionary algorithm ended up doing. So we can see here that was the solution they were looking for. But here's one where it figured something else out entirely. So what it does is it curls around on itself and it jams itself over the block, which ends up grabbing the brick, and then it can move the brick around however it wants. Here's another one where it takes a swing at it and ends up being able to grab the brick and move it around. And these are truly creative things. These were not programmed by the programmers or the researchers. They were developed entirely independently by the program evolving these different solutions. And I thought these were super cool. Yeah.
It is totally cool. It shows the diversity of solutions that an evolutionary algorithm can come up with, because it's not already preloaded with the biases that we tend to have about how things should be done.
Yeah. Yeah.
So this is an article that I ran across that I think is got some similar concepts in it. And it's talking about the use of evolutionary computation to make computers that can program themselves. And this is an idea that's been around, as the article mentions, for over 60 years. Yet we don't have this yet. We don't have this in a practical way. Mm-hmm. We have this in a scientific and theoretical way. There's a lot of theoretical work that's been done on this, and we have written computer programs that successfully write computer programs to solve problems that are challenging for programmers to write programs to solve. So there's proof that there's validity in some of these capabilities, but the real question is how come we're not using these techniques today? And the article addresses a couple of issues about why these techniques have not been adopted. And a big part of the reason is what we saw with especially the little gripper example there. So while that was a solution, that's not a solution that most of us would want, mm-hmm. right? If we want a gripper that's able to grip a block and locate it somewhere else, smashing the block against your body and smashing your gripper down onto it and then flicking it, or flicking your gripper against the surface in order to force open the jaws so that it can grip it. These are not ideal solutions. So these come up with solutions that work based on our fitness metrics. And if we're not careful in specifying our fitness metrics, then it finds these solutions that are otherwise not ideal.
Yeah.
And then the other thing that comes out is a lot of the solutions that get evolved are too complex for humans to understand. So they may work, but none of us are smart enough to figure out why they work.
Yeah.
And the problem with this is if we can't figure out why they work, we won't be able to figure out under what situations they won't work. Mm-hmm. And so there's an inherent risk that under some critical situation, this thing may fail to do its job properly, and we don't have any way of proving that it will or won't do that.
Right.
So there's still a lot of risk in this area. But there's a lot of potential there as well. And current development of machine capabilities is kind of breathing new life into this area of research. Plus the fact that we're trying to solve ever more complex problems. The demand for software developers is always accelerating beyond the supply. So these pressures are pushing us in this direction.
Yeah.
And then here's another article that I ran across that I think is a step beyond these other articles, but still in the same vein. And this is a researcher from Google with Google's Brain Project. And this is a picture of him giving a presentation where he's demonstrating teaching a computer to create music in the style of Bach. And the way that he's teaching the computer to create music in this style is by playing a little bit of Bach and then having the computer attempt to create what comes next. What should be the next few notes after this, and then giving the computer feedback on how well those notes meet the criteria. So again, it's a kind of an evolutionary process, but the application here is what fascinates me. So we currently have digital assistants, things like Siri on your phone, or OK Google, or Alexa, the Amazon digital assistant. And these are very practically focused applications of artificial intelligence. They're there to help us manage our calendars and appointments and look up information and make phone calls or navigate, in our cars. But this is a completely other activity that digital assistants can be leveraged towards. That's the production of creative material, things like art, music, literature. And while we use computers as tools for that now, in the production of those materials, we don't yet use them as collaborators. And I think this is something that's coming, and that's what this article is about, and this particular researcher is interested in. Can we create software systems that effectively collaborate with humans in a creative way to enhance the creative capabilities of humans, not just to augment them, but to actually enhance them in the same way that working with another creative human has those same advantages. And I think that we're going to be seeing a lot of this coming very soon.
Yeah, it's the idea of a computer rather than as a replacement, as a sort of partner or an augmentation, rather than the typical, this is going to take my job. It's not going to take my job. It's going to make my job easier, or it's going to make my job make me more productive, right? And I think that's an interesting gray area sort of thing.
Right. Or in this case, not just more productive, more creative.
More creative.
It's a different kind of thing.
Right.
I mean, the promise of computers and making us more productive, I think, has been realized. We are more productive with computers.
Right, totally.
But are we more creative? I'm not sure that we are.
Yeah.
And this seems to me like it raises that not just as a possibility, but a probability.
Right. Yeah. That's fascinating. That's totally fascinating. Well, that's all we got for today, guys. So thanks for watching, and keep plugging away in the class. We finished grading the variables assignments and the developing an algorithm assignments. Those all look fantastic. You guys are doing great work. It's pretty quiet in the discussion boards, but remember that we're always here for you guys to help answer your questions about anything at all. So it doesn't have to be about the course content. It can be about careers in computer science, or what it's like at a big college, or just interesting computer stuff in general. So If you have anything you'd like to talk about, let us know in the discussion boards, and otherwise we'll see you online.